Making decisions from data sources. This is a presentation by Michael Martin, a graduate student at the University of Alberta. As human beings, we're able to make decisions based on our knowledge and our experiences. But what about computers? How can they figure out what to do, when to do it, and why to do it? What knowledge and experience do they have? By using a mathematical algorithm, a series of ones and zeros, computers can make decisions. They use logic trees to make simple yes or no decisions. Sometimes these trees are combined to make complex decisions. In digital video surveillance, we use biometrics. Biometrics are algorithms that are able to scan a human being's eye and make identification from the iris, or looking into the eye and do a retinal scan to see who they are. We also use facial recognition and do geometry on a human's face and mathematically map that face. Encoding fingerprints has been done for over 100 years. Nowadays, we're now doing palm prints as well as scanning veins within the hand to identify a person uniquely. Analytics are another form of mathematical equation to help make decisions in video. In this example, we see a room. In the room, a person enters and will leave an item behind. The jacket is removed and left on the podium, but the bag, which was separated from the person, was taken away. An alarm indicates an object that has been left. In the next scene, the quad split screen demonstrates the video in the upper left corner, a invisible line in the lower right, and a snail trail in the left with an icon symbol in the right. We can see that the alarm will be tripped when a person enters the virtual area. Likewise, any other objects will be identified. In this scenario, we're seeing a camera reading license plates and recording the license plates into a database for subsequent use. They're also taking images of cars as they go by. In this image, what we see is a person walking around a room. This is a new form of algorithm that is used to help in the aid of capturing faces for facial recognition software. If we don't have a good image of the face, then we cannot compare it to a library file and know that we have the same person. So image capture is critical. This software is able to identify the head on the human being, and then when the head is known, it drives the camera in to zoom in and capture the best face picture possible. It's a very powerful piece of software that is unmanned and is a precursor of things to come. In conclusion, knowledge harvesting technology is changing rapidly. Applications are diverse. The value from a knowledge management perspective is increasing exponentially. Integration with other systems, like biometrics, magnifies the knowledge power of video surveillance. Computers can do far more than man can do, and they work 24/7 without a rest or a coffee. Knowledge becomes ubiquitous. Any network, any time, any place. Vast amounts of storage is required, and the archives fill quickly. The collection of data becomes overwhelming, and therefore decision data mining tools are necessary to harvest the knowledge from the data archive. Privacy policies are essential. It is easy to abuse this knowledge source if used without regard to privacy and the laws of the land. Thank you for your time today, and thank you for your interest in making decisions using data